So bear with me on the screen up here. This is Partworks software from ShopBot. It's actually Vectric is a company out of England that makes it. And one thing that I love about this, the Vectric software by itself is about $1,000. And of course it comes bundled with the machine. So that's part of the cost of the machine. If you make your own or you buy someone else's solution, you may not get this software. Essentially, I'm going to start and create a new file. So the first thing you do is set up your job. You tell it the size of your piece of lumber you're going to work with. So in this case, 5.5 by 23 and something by about a 1/2 inch, and you tell it where the origin point is, which is, in this case, I want the origin here. And that makes it easy to calculate because when you place things on here, this is CAD and CAM all at once. You can design in this, you can also create the toolpaths. And what do I mean by CAM? CAM is computer-aided manufacturing. If I just draw a square in software, the computer and the CNC machine, they don't know what to do with that square. Does the operator want it, does he mean I'm going to cut out around the outside of it? Does the operator mean I'm going to cut out inside the line? Does he mean I'm going to cut on the line? What size bit am I going to use? Because if I could give this same rectangle that created this, but put a bigger bit in here and get a totally different physical product when I'm done, right? Does that make sense? I got some concerned scowling looks. Maybe you're just mad at the phone. So essentially, you have to tell it the kind of bit you're using, the profile of that, the size, and then what to do, how deep to go. That's the CAM aspect of it. And that has gotten a lot better over the last 20 years as far as the user friendliness of the software. Way back in the day, you literally programmed that by hand. So, you know, it's...
Which was awesome, by the way, right? That was cool people back then.
Well, all right, so John is going to be our manual. He's going to revert the ShopBot to program with patch cords and punch cards. He's going to turn it into a jacquard loom. Which historically, by the way, that's kind of the first instance of this kind of technology is the jacquard loom. It was a device to print out patterns when you make cloth that used punched cards. And more modern CNC started during World War II. Anybody have an idea why they needed it in World War II?
Code. Cryptology?
Well, no, not for the cryptology. They used it for airplane propellers. Because you have a propeller, that's a complex geometric shape, right? And they were still working out all the laws of aerodynamics, so you also have to put it in the material and keep the material from breaking because they were making them out of wood, right?
The Jim could turn it on a lathe just with his tool hand.
I know.
Also making them in volume.
But in volume, though, because think of how many airplanes they turned out. So they would create their design, they would mechanically model it, they would make punch cards that they could put through a machine. The punch card patterns described the geometry, and then a router on a frame would go and move as it was told to shape out that contour. So that was sort of the first use in the early 1940s during World War II. And then it kind of built from there, and then as computers became cheaper and more available and easier to use, because keep in mind, if you were a factory in 1950, the computer took up a room this big somewhere in an office building to do your payroll, not to run your machine. So as soon as PCs and cheaper computers came out, then you could actually have standalone machines that were more affordable. And then, of course, you get to this level. So we've got our blank, we've got our origin that allows me to design things. So if I want to put something 1 inch over and 1 inch up, I can start from this 0, 0. And that's how we're used to looking at coordinates. You can adjust it and put it wherever. You can tell it whether you want to work in inches or metric. So whichever way you'd like to go. We've got, so I'm going to accept this. All right, next up, we can do all kinds of things. If I want to draw something, let's say I want to put a circle on here, I can manually draw it. I can type in the coordinates for the radius or diameter where its center point is. I'm just going to grab one. We can make a joystick. That's what John and I did. I'll show you the file for John's Farfall joystick here in a second. So I've got circle on here. Now, like I said, now what do I want to do? Do I want to make this into a pocket? Do I want to, I'm going to make it into a pocket. So I'm going to come over here and make a toolpath, and this is kind of hard to see at a distance. But it shows pictures of what the router bit's doing in the wood for each one, so it's pretty easy to understand. And then you just fill out this little form. It basically says your start depth. Well, 0, I told it 0 is the top of the wood, so if I machine it down to 1 inch, that's going to machine 1 inch into the wood. So that's kind of in reverse from what you might expect. You think of things getting higher numbers as they get taller. We're machining in. I'm going to machine in, this piece is about 1/2 inch thick. I'm going to machine into 0.38. I'm going to tell it that I'm going to use a 1/8 inch straight bit. I can adjust how it cuts, the direction, conventional and climb cuts. This gets a little technical, but basically if you've ever used a router, you have to know that the bit's spinning in one direction or the other. And by the way, a Dremel tool versus a router, they spin in opposite directions. So some people that make their own homemade CNC machines don't realize the Dremel's in reverse. You kind of have to reverse everything when you design if you're doing that. Because the cutting tool only cuts in one direction. If you think of it just a regular wood plane, a hand plane, it's going to cut in the direction that the blade's touching the wood, but it's not going to do anything if you pull it backward. Same thing with the thing. So the direction that you take your bit around this, I'm either going to go over clockwise or counterclockwise depending on which way the cutter on the bit is. And this one only goes in one direction, but I do think they even make them little advanced spindles that you can go either way. So if you had a need, you could do that, or special bits or whatever. So that's something you pretty much leave it as climb cuts and go in the right direction, you'd be fine. You can make allowances. What an allowance is I designed my part to be exactly 1 inch, but maybe I know it's going to go into an assembly and I need some clearance. So you can build in an allowance, and that way you can work from a geometry in your design that's exactly what you want, but then when you cut it out, you add the tolerances in what you cut out. So if you're familiar with drafting and geometric tolerancing, you would design it exactly the right size, then you put a note about how far off it's allowed to be. Because materials do, well, you would know all about that. So that's the idea, is this allows you to do your tolerancing. And then how you're going to ramp in and out of the material, and you can give it a name, and you can tell it, this is going to select the vectors manually. There's just one. Oh, whoops. I have a vector selector. Whoops. All right, so now it switches me to my three-dimensional view. So here's my piece of wood, and this blue circle, all these spirals show you where the router is going to go. So that shows you the toolpath that you've created. So what you can do, I can even preview it and see it physically cut it out. And it showed me how it's going to cut it out, so I can move it around and look and see how things fit. Is that what I want? Is that what I expected? And the cool thing about the software now, I used some stuff like this in college in the 90s that was on an Apple II. Wasn't on a TRS-80. So. But you had to be careful because, for example, if the router was in here cutting this pocket, when you were done and you wanted the next cut this pocket, it would say, all right, I'm done here, and just go over and cut a hole right in the middle of this. It didn't know I got to come back out, go over, and go down and avoid cutting the middle. So you would actually have to run it. And a practice that was pretty common back then was to do your design in wax. Cut it out in wax first to see, all right, where are all your problems? And then you would go manual, because the software could only get you so far. Then you would take the code the software generated and manually tweak it to fix those problems. So we've come a long way that this more or less, I've never had an issue. There's probably some mistakes it can make if you got really complicated, but...
Well, the frustrating thing was you could write the best damn program that was ever written and you'd be the only person that knew it. But if you made one mistake, everybody would know it.
Right. And so you had to be careful. This takes a lot of that into account. Now I'm going to, let's see, I can show you a cutout with the tabs because you asked about tabs a minute ago. I'll go back to my two-dimensional view. I'll put myself a square here. And now I'm going to cut this square out. So I'm going to make a profile cut.
Don't you just select it first?
It's selected.
Ah, okay.
It should be. And
would have those dots.
yeah, it's telling me that the red tells me it's selected.
Ah,
And then this cutting depth tells me how my starting depth and my cutting depth. If I'd already, let's say I'd already machined this out and now I want to cut a hole in the bottom of this floor. Well, you do have to be smart enough to know that if I cut this out first and then I said cut the hole, it would start at 0 and it would machine in the air for a minute before it hit. That wastes time, it sits and lets your machine run. So you can tell it what depth to start cutting at for the next pass. So you do have to be aware of that to speed things along. But obviously, it's not smart enough to know what you're thinking, right? So it is better than it was. So this I'm going to cut out, and I'm going to add tabs to it. And you can adjust the tabs. My router bit, I'm cutting kind of a small piece here. My router bit's a 1/8 inch bit. So I'm going to leave 1/8 of an inch tab width and height on it. Now, when you're doing this, you can be very accurate X and Y to your 0 point. Your depth depends on how good your zeroing is, and I'm going to cut all the way through. So I set this is 1/2 inch wood. I got a vernier caliper out and measured it. It's 0.498, and because that's how deep they sanded this piece was sanded probably. And then that also reflects the humidity today. Tomorrow it might be a little more, a little less. So I'm going to make my file be 0.51 so that I guarantee I cut all the way through. Because what will happen is if you're very conservative about your depth, you'll leave material on the back and you won't cut all the way through, which can be fixed by doing a second pass, or you can trick the 0 and move it down and cut it again. It also depends on whether you're cutting a part out 1,000,000 times for production purposes versus I'm just making one today. Or you might have just cut it out by hand if you've got this paper thin. When I did the prototype of our foot power lathe, we did that on plywood at ShopBot. We were running out of time. The Maker Fair was 2 days away. I just cut the rest of the first piece out with a carpet knife because that was the fastest thing to do. So it all depends on how good you want to go. So I'm going to add these tabs and I'm going to edit them. So I'm going to sell it 4 and I'm going to just have it add the tabs. And you see these little squares that popped on here, it added them for me. Well, I don't like where it put this one. It put it right on the corner. I'm going to zoom in. It put it right on the corner here. So I'm going to, let's see, I'm going to move it around. So you can just grab it and move it where you want it. And it will try to space them out, and it kind of goes by rules based on, you know, you're going to physically cut this off of here. You're going to sand it off here. This piece still has a 3D tab left. I left it on there on purpose. Depending on how you cut it off, how you sand it, what kind of material you have, you'll leave a witness mark from your tooling. So kind of a rule of thumb is you don't put them right in the center of things. You put them off to the side so it kind of looks like a natural blemish or a nick or something. And again, with a little 1/8 of an inch, it doesn't matter. And the bigger, if I'm cutting this out of a giant sheet, you won't notice a little 1/8 of an inch piece at all. If I'm cutting a 1/2 inch piece, you'll notice it like crazy. So it's kind of all about that. So here I'm going to accept those, and I'm going to calculate this tool path, and it gives me a warning. It's smart enough to tell me, hey dummy, you're going to cut all the way through. You better make sure you have a spoiler board so you don't mess up your expensive router. So that's kind of a nice little feature it does. It reminds me how dumb I am every time I use it. So that's a useful thing.
Sounds like a wife.
So I just previewed this tool path, and you can see the, I'm just not going to say a word. So you can see just like on this real piece of lumber, you can see the tabs down in there. And so that way I can cut this piece out, I can do that. So all day long you can set, you can put text on here, anything you can draw, you can put on here. You can also import from a CAD file, from a regular AutoCAD file, you can import. With this, you can do bitmap images. It depends on how complicated they are as to how well it will cut them out. You really need the PhotoCarve software he was talking about to do serious work with photos, but I've not used it for any of the stuff I've done for logos and things so far. It just depends on what you want to do. Questions at this point? I'll show you the fillets. So I'm going to make myself, another rectangle, and this time I'm going to come in and I'm going to make some fillets on it. So here's my choice, normal, dog bone, T-bone. I'm gonna make a dog bone fillet, and you can tell at the radius. You can do anything from the tool diameter up. So I've got an 1/8 of an inch bit, so I could have an 1/8 of an inch. I don't really need that because I already would do that anyway. I'm just gonna leave it at 1/2 to be exaggerated. You just click on the corner and it'll make those dog bones for you.
So when you're making your kits, do you design the entire kit in CAD and then take each of the parts out and then enter them in?
I
separate-
designed when I redid them here from doing them manually, I just drew them all in here because it was just as easy to draw them. This is 10,000 times easier to use than CAD as far as drawing simple things go.
Did you bring any kits a little?
I do have some parts from my kits. This is, I'll pass these around. This is a telegraph key assembled for my Reinventing Morse kit. This is cut out of the PVC lumber. The top button, turn it upside down and sit it in front of it, and it machines it out of a 5-inch piece. And this does it through, there's several pocket passes that it makes. And what I found, another interesting thing is, all right, the way I was doing it is I was cutting out this pocket, and then when you're done, you cut out the whole shape. Well, that was actually leaving a paper-thin wisp of plastic around the edge. And part of that's because your bit is not necessarily within thousandth of an inch. It may not be exactly 1/8, and the material moves out of the way. You know, there's a certain point where you machine enough away that as you're cutting it, just pushes it out of the way versus cuts it. So what I did when I redesigned it is I cut this out at an exaggerated, you know, move the bit over a little bit so that it's cutting that out on a bigger pocket, and then it cuts on the inner part that's smaller. It takes away that problem altogether. So this machines out the edges, it cuts the holes, it does everything. These are some parts of a prototype I did that shows how joints can be made. And you might imagine this was cut out of the same, you know, actually this was cut like this, out of the same 5.5 lumber. So essentially this was, so it's also about maximizing your material. And these two big holes, this was a crank that goes on the top, so this comes, and there's another base for another piece that comes out of here. This is the top, and even the handle for the crank comes out of this hole right here. So you use everything and put it together. And this has a hexagonal hole. I machined that roughly as a hexagon, but it's going to have rounded edges, and then the drive shaft, the thing that this drives when it's put together, if you just pressure fit that, this stuff's soft enough, it just moves out of the way, then you get a nice fit. But these go together, and you can see the dog bone and fillets on this so that this will physically go together.
The Alamance Makers Guild is a group of talented and creative makers located in Alamance County, North Carolina, and is sponsored in part by Harris Educational, makers of reinventing science kits like Reinventing Edison Build Your Own Light Bulb.